So I'm moving on to chapter 3 of Machine Learning by Tom and Mitchell. Read through. I'm at pages 52 through part of 55. So it's basically an introduction to decision trees. The whole chapter is on decision tree learning. And they state that decision trees are great for discrete value targets, meaning target functions, meaning if you're trying to figure out whether I don't know, you're trying to classify it into, it's a classification algorithm. So yes or no, good or bad, or it can also, it doesn't have to be one or the other. It can be multiple values, but it's finite. So yeah, so that's what decision trees are for. You're trying to classify instances correctly. And the way they work is that it takes, so you have many attributes. Let's say you're trying, in their example, they're trying to decide whether it's good weather for tennis. So some of those attributes would be the outlook, the humidity, the wind, and what the decision tree algorithm tries to do is to see which of those attributes by itself best accurately classifies the overall problem. So, for example, is outlook, basically the weather, is that a better predictor of the overall outcome of whether or not it's good weather to play tennis, rather than the humidity or the wind? And then so that's where it starts with the root. And then it breaks it down. Okay, if it's sunny, or if it's overcast, or if it's rain, is there humidity? Is there wind? Because those would be the next best, what they call nodes, to describing the overall, to classifying the instance. Which is, the instance would be a day, a day that is sunny, humidity's high, and the wind is weak, for example. So there's that. They also talk about this concept of that decision trees represent a disjunction of conjunctions of constraints on the attribute values of instances. And basically what that means is you have I got it in my notes here. You have so a conjunction is basically an and statement. So for instance, it's sunny and and there's high wind. That would be a conjunction. A disjunction is or. So it's sunny or it's rainy. It can't be both, right? Technically it could, but in this example, it can't. So they say that it's a disjunction of conjunctions. So it's either, so an example would be, it's a disjunction of conjunctions. So it's either sunny or it's rainy, and it's high wind and it's low wind, right? So you have a conjunction there of it's windy and it's rainy, and you have a conjunction of it's sunny and the wind is low. But it can't be both at the same time. So that's why it's a disjunction. For clarification on that. So it talks about these pages also talk about instances being represented by attribute value pairs. So the attribute would be temperature and the value would be hot, or basically the way to classify each attribute, or a classification of each attribute. Says the target function has discrete output values. So you're trying to classify either yes or no, or right or wrong, or you can use multiple. So you could use good, okay, bad, but that the target function it's not a continuous, it's not trying to represent a probability of something, for example. Disjunctive description, we went over that. It's also good with when the training data may contain errors. It would detect errors, whereas the candidate elimination algorithm, or what were the other ones that I talked about in chapter 2? Nope. Come on, chapter 2. The candidate's elimination algorithm, the find S algorithm, find specific algorithm, or the lists then eliminate algorithm. None of those algorithms can actually tell you whether there's errors in the training data. But with the decision tree algorithm, it can. So that's an advantage. You can also do it when the training data contains missing attribute values. So for example, you might not know what the humidity on a certain day was for whatever reason, or in a more realistic example, if you're trying to detect whether patients have cancer or not, you might not have a specific blood test that could be an attribute. But based on other values, you could realistically assume or induce a value or for that attribute. And that's that's pretty much it. It introduces some like a specific machine learning algorithm, which is ID3, and its successor C4.5, and that's mostly what it talks about. Thanks for sticking with me through this video. Hopefully that helped you. Definitely helped me to kind of explain it to myself and understand what I read.